Okay, this is integration packet number 24 and problem number 7. So we are asked to find the integrals, and along with that we need to remember U substitution, and not all the integrals relate to inverse trig functions. So if I look at part A, I have the integral of 1 divided by square root of 1 minus 25x squared dx. So, well, if I'm going to try to remember U substitution, then I would try U equals 1 minus 25x squared, which means du would be negative 50x dx. Well, that is problematic because of this x variable right here. If it was just negative 50 dx, I'd be fine. I could put in a negative 50, compensate with a negative 1 1/50th, and I'd be fine. But on integrals, it's okay to put in constants, but it's not okay to put in a variable. So U substitution is not going to work in this case. So since it's not going to work, I'm going to have to try to think about some inverse trig functions. Well, we've looked at the derivative of the sine inverse and the tangent inverse, which I have shown down here. Okay, sine inverse and the tangent inverse. Well, because the sine inverse has a square root of 1 minus u squared, I'm going to see if that our question would work in there, if I could try u as a different way. So if I say my u is just 5x, okay, then u squared is 25x squared, which that means I have 1 minus u squared, and du would have to be 5 dx, so I'd need to put in a 5 so I could substitute directly for du, and if I put in a constant I have to take out its reciprocal, so I have 1/5, and now that is in the perfect form for a sine inverse. Okay, so I have that integral is going to be 1/5 sine inverse of u plus c. We started out with the integral in terms of x, so I need to end up with it in terms of x. So, and u is just 5x plus c. So if I look at part B, I could try to go through the same process as I went through here and try to determine whether it is a typical U substitution before trying my trig inverses. So if I have U to be 1 minus x to the 6th, then du would have to be negative 6x to the 5th dx. Well, again, that's a problem because I don't have an x to the 5th, I just have an x to the 2nd. Okay, so I'm not going to be able to find what a typical U substitution would be. So this is not going to work again. So if I go on to think about a trig inverse, well, I'm going to again think about a sine inverse, and I'm going to think about that. Sorry about that. I'm at home and my phone just rang, so let me get back to this. I was thinking about this problem B with 1 minus x to the 6th, and since it's a square root and I've already determined that a regular u substitution doesn't work, I'm going to look at a sine inverse and try to figure out what u might play into this problem, if I could find something that would work exactly as it's supposed to. So if I try now on these kind of problems, I really am focusing in on what would u be, right? And it's this term right here, because I already have a 1, which I need. I have the square root which I need, and now I have an x to the 6. Can that be something where u is something else? Well, if u is x cubed, then u squared would be x cubed squared, which is x to the 6, which is good. All right, and the reason why that is very good is because du, taking it from here, would be 3x squared dx. So all I need to do in this case to make my substitutions work exactly as they need to be is if I put in a 3 right here in the numerator, then these 3 terms are going to make up du, because I have the 3, I have the x squared, and I have the dx. So those would make up du, and then I'd have 1 over square root of 1 minus u squared. Okay, I can't put in the 3, however, without compensating with its reciprocal of 1/3. And then I am in perfect shape for a sine inverse. So it's going to be 1/3 the sine inverse of u, but u is, and I'm going to do it right away, x cubed plus c. The last one that I'm going to do out of this set of problems is c. So I'm going to go through the same process again. Can I find a u that is a direct u substitution before trying to go to trig inverses? So I'm going to try what's underneath the square root sign, which is often a good way to go. So if u is 1 minus 25x squared, then du, the derivative of 1 is 0, derivative of negative 25x squared is negative 50x dx. Okay, well that's good because I have an x, I have dx, so I only need to insert a constant, which is allowable. You can't insert a variable, but you can insert constants, which I think you probably understand by now. So a reciprocal needs to be compensate for what you put in. So I'm going to have negative 1 over 50. The 3 terms here again, they all take care of du. So I have 1 over, that is u squared, the 25 minus x squared, I'm sorry, the 1 minus 25x squared is u, so I have the square root of u. That's all u. So in order to solve that, I can think about that as u to the negative 1/2 du. So I just have a polynomial, and I just have a power rule. So I have to go to u to the 1 higher power, so the exponent to 1 higher power divided by the 1 higher power divided by 1/2 is the same thing as multiplying by 2, u to the 1/2 plus c. 2 goes into 50 25 times. U is, substituting what U is, 1 minus 25 x squared plus C.